Hi everybody, now turn to question 9 in your similarity applications of similar figure packet and we will get going. Okay, so in this one, this is going to be using something called indirect measurements to find a missing link. So this is very telling toward how we can use similar figures in the real world. So it says to find the distance x across the river. So sometimes objects are hard to measure. Like sometimes it's really hard to take a measurement of like the distance across a river. Okay, or other things like it's kind of hard to measure the distance across a volcano because you could fall in the volcano, right? Or maybe you're on top of a mountain and you want to figure out how far it is to the other peak in the next mountain. Well, sometimes these measurements are hard to do on your own. So you can use other objects and use a proportion to kind of approximate the distance of different things. So it says to find the distance x across the river. So we're trying to find this distance across the river. Okay, and obviously the surveyor cannot do it very easily. So the surveyor is going to use similar triangles to actually find the distance across the river, which is really neat. Okay, so a surveyor located points A, B, C, and D through direct measurements. So this surveyor was able to get measurements on this side of the river, but the surveyor wasn't actually able to get measurements across the river. So using the similar triangles, now the surveyor can find the distance across the river. Okay, so it says find the distance from the tree to point C, which that will be our distance across the river. Okay, and the measurements that the surveyor got was that C to the D was 75 feet. C to the A was 25 feet, and A to the B was 100 feet. Okay, so these were distances that the surveyor was able to measure through direct measurement and then through indirect measurement. So without actually measuring the distance of the river, across the river, we're going to be able to find it. So that's why similar figures are actually really important in the real world. Okay, well, let's get going, you guys. So they already have these parts labeled. Now remember, sometimes if you guys see in our picture, we have a triangle that is within another triangle. Okay, so it's really helpful to separate your triangles so you guys can visualize what's going on a little bit better. Okay, so if we look at our big triangle, the distance from A to the tree, well, this distance is made up of two distances. It's made up of the distance AC as well as the distance from C to the tree, which I don't know, so we're calling X. Okay, so if this distance is 25 and this distance is X, what would be the entire distance of that side of the triangle? How would I find this side if we have two parts that make up that side of the triangle? Well, we are going to add them together. Okay, so I'm going to call this the height of the triangle. We don't really have parts really that we can call each thing, so I'm going to call this the height. So to get the height, we're going to add these two pieces together. So it'd be 25 plus x. So 25 plus x. Okay, so this entire side right here, the way we find it is by adding these two together. So it'd be 25 plus x. Okay, so you can either label that on your picture or on a separate triangle, whatever makes sense to you. Okay, and then we're going to call this way the width of our triangle. So our width is going to be 100 feet. So 100 feet. Okay, so our height is 25 plus x. Our width is 100 feet. Okay, so that is the large triangle. Okay, now let's look at, so that's the big triangle. Now let's look at the smaller triangle. So I'm going to call it the small triangle. Okay, so what is the height of the small triangle? So the small triangle is this one right here. What is the height of our small triangle? It would be just plain old x. So our height is going to be x. Okay, and then our width is right here. So again, this is our height. Our width, how wide does this triangle go? It is 75 feet. Nice job, you guys. So 75 feet. So this is our width. Let's call these widths. Okay, and again, this is our width right here. Okay, and then using this information, we can use proportions to approximate the width of our river. And our river width is going to be used with an x. So we're going to represent that length with an x. Okay, so when we find x, we'll be finding the approximate width of the river, which is really, really awesome. Okay, so let's get going. So we're going to do the height over the width. So height over width. Again, it does not matter though which one you pick. So you could do width over height or height over width. Whatever floats your boat, really. So width. Running out of space. Sorry, that says width, you guys. Okay. And why did my screen freeze? Stop that. Okay. Now let's keep going. So I'm going to start with the big triangle. So the height of the big triangle is 25 plus x. So 25 plus x over the width of my big triangle, which is 100. Okay, and if you want to put the units, you can, so it'd be feet. And then the height of my smaller triangle, I don't know, so we're calling that x. And the width of the smaller triangle is 75 feet. And guess what? From here, we just cross multiply. So let's get going. Okay. Doesn't matter which way you start first. I'm going to start this way first. Might as well. Okay, so I'm going to be multiplying 75 to the entire expression. Okay, the entire expression is 25 plus x. So I need to multiply 75 to that entire thing. So I'm going to group this thing in a parenthesis. So it'd be 75 parenthesis, I'm multiplying 75 to the whole thing, so 25 plus x. Okay, and that will equal, let's go the other way. So that would be 100 times x, which is 100x. And then from here, we just solve for x, you guys, so let's get going. So how do you deal with a number outside of a parenthesis? You would distribute it. You guys are so smart. Okay, so I'm going to distribute 75 to both of these numbers. Okay, which 75 times 25, that's going to be a very large number. Again, since we're dealing with very big numbers and sometimes with decimals, if you'd like to use a calculator, it is okay in this situation. Okay, so 75 times 25 will give me 1,875. So 1,875, and then 75, sorry guys. Okay, so then 75 times x will give me 75x, and that will equal 100x. Alright, so currently my x's are separated, which means I need to join them together. Okay, so how would you move a positive 75x to the other side? You would subtract. Like normal, you guys are on a roll. You know everything. Okay, so 75 minus 75, that will cancel and turn to 0. 100 minus 75 will give me 25x. Okay, so we're left with 1,875 equals 25x. Alright, and now we just have one more step, which the 25 and the x are secretly multiplying. Which means the way that I'm going to move 25 over is by dividing both sides by 25. Okay, 25 divided by 25 will cancel and turn to 1. 1,875 divided by 25 again. If you need to use a calculator on this one, it's okay. So divided by 25 will give me 75. So x is 75, but 75 what, you guys? What are the units for this problem? What did the surveyor measure? What units did the surveyor use when the surveyor measured the different widths and heights of these two triangles? Which in this case, he really only measured like this bottom part of the triangle, but you know what I mean. The surveyor did measure them in feet, so it'd be 75 feet. So the approximate width of our river is 75 feet. So this is a way that either surveyors or different types of measurements can be used to find measurements that are hard to do, like the width of a river or things like that. So this is called indirect measurement, and that's when similar triangles are actually used quite a bit. So there you go. Okay, we have one more example problem we're going to do together. So get going on question 13.